So Alex, we had an announcement from Meta about about a couple of weeks back in which they described something which they call the super research cluster. And the scope of the super research cluster is probably, as they say, the vision is to become the fastest data center for processing AI type workloads. In that, they named NVIDIA, yourself, and one another partner, another vendor, as the three key partners for the whole setup. So, considering this early brief, would you like to give us an idea of what is Pure Storage's involvement in this super research cluster, and then we can go into more details.
As you know, we've been working with the Meta team since 2017 in the initial, as was then, FAIR artificial intelligence research system. So that was with initial deployments of our FlashBlade technology. And since that time, we have been working with them and developing our stronger engineering links. And since 2020, we've been working with them to develop the RSC, the research supercomputer, which is, as you say, a partnership of primarily ourselves and NVIDIA as the storage partner with the Penguin caching compute layer in between times. And really the aim of this system is to become the world's largest AI computer over time and to help the Meta scientists work on some of the more challenging problems they have around computer vision, language processing, and a mixture of other technologies that are being used more widely in learning systems and intelligence systems today.
Okay, great. Now, typically AI type or large superclusters or large research clusters have been used for use cases such as weather modeling and population statistics where the data sizes are huge and the modeling requirements are complex, like for example the birth of the universe and things like that, where the data is huge and the processing required is also enormous. When you're making a research cluster, I mean, it's called super research cluster like this, do you think it's still suitable for research type of use cases, or does it also enter the realm of commercial type of use cases?
So I think the way in which machine learning technology works in general is that the larger the system is, the more powerful it becomes. And dividing up into smaller segments is perhaps less appealing to scientists unless they are working on a smaller training model. So yes, it can be applied to smaller or even more generalized commercial use cases, but the power of the system really becomes much more strategically capable once you use all of the NVIDIA GPUs against a single model that has been trained and developed with enough calibration points. So I think in answering that question, the bigger problems are the ones that the Meta team hopes to solve with the RSC rather than specific ones.
Okay, understood. Now tell us, the coming together of NVIDIA, Penguin, and Pure Storage, what was the vision here in terms of the technology architecture? How was it put together? If you can, as you said, you were associated with them with the previous data centers. Going forward, what was the vision to scale? I mean, what was it look like? We know it's supposed to be the fastest, but from a technology point of view, how was the vision described to you? Go ahead.
So the project to build, create, deploy this system itself is pretty fascinating from a number of different dimensions. First of all, obviously, Meta already had a data center built for exactly this purpose. So we knew that fitting into the constraints of physical space as well as power density and all of the usual floor space, tile space arrangements were already set in stone, quite literally in this case, so could not be changed. The Meta team were already working in the pandemic era, so on-site collaborative meetings were difficult. What we essentially ended up with was the decision to build a scalable, repeatable system that could be expanded in exactly the same way as the initial deployment. So building from an initial 250 petabytes of capacity with 6,000 or 7,000 of the NVIDIA A100 GPUs, but then repeating that in the same facility, but just expanding the capability over the next, hopefully 6 or 7 months or so. So designing for scale, designing for resilience, as well as making sure that it fit within the metrics of traditional data center requirements in terms of power, space, cooling density, but also leaving room to grow. The ambition, as you know, is to reach an exabyte of model data, but also to get up toward 16,000 NVIDIA GPUs in the system as well, all of which drive specific requirements on the storage side in particular for the density and the actual bandwidth density performance density, and power density. And we had some very, very lengthy discussions with the Meta team in terms of fulfilling those requirements.
Fantastic. So you mentioned a very important point that the basic data center structure had already been established in 2020. So are you saying with this scalable vision of being able to replicate, like you said, there wasn't any need to do a proof of concept? I mean, you didn't actually have to do a repeatable, scalable, small proof of concept to see if it would work. Is that the case?
Well, no, the Meta engineering team are very capable. They have a very good sense of what they can achieve internally with their own tools, their own technologies, as well as the capabilities of our competitors. But ultimately, they chose to go with us because we were able to already demonstrate years of working together successfully, not just on the engineering side, but also on the support and the professional services and all the other relationships that go with that when you build a system at that scale. So we already had that advantage of being the incumbent and having demonstrated all those capabilities. But the real design points came to, can you fit this much capacity into this much physical space? And can you consume this much power while delivering enough bandwidth to feed and sustain all of those GPUs at once? And that was a pretty big design point for us. And we did actually make some enhancements to our own software to help the Meta team reach those goals.
So a very interesting 2 points you mentioned over there. One, that means you did do a small sort of concept in your own premises, in your own factories, to make sure that the equipment met those requirements. And the second one was obviously where there was some sort of, looking forward as to how the equipment would be replicated. That sort of thing had already been done internally. Go ahead.
Yes, we already had strong levels of confidence we could meet the requirements. The Meta team had produced a very comprehensive specification for all of the parameters that we had to reach. So we were very clear on that capability. But obviously, the other side of this was, for example, the logistics of how do you deploy hundreds of systems easily, quickly, link them all together to produce a single set of data sets for ease of use. I mean, Pure is well known for its elimination of complexity, but we wanted to make sure that this is a unprecedented scale of deployment in a single data center in a very short period of time. So we wanted to make sure that this could be done quickly and easily with almost a plug and play type approach for the storage deployments themselves. So thinking about all those traditional deployment requirements, but also some of the non-functional requirements that sat around that as well, were part of the major success keys here in actual go live and making it a successful program.
Okay, so interesting. So the second point, which you did mention, also interesting, was the role of software. Now, Pure Storage has been looking increasingly into various software parts of the solution other than your hardware. I mean, you have Fusion, you have Pure One, and things like that. Was there any specific software which you had to look at for Meta's Super Research Cluster that helped manage the energy or help manage the scalability better?
So I won't go into too much details on the actual physical enhancements to our software. What I will say is that one of the big Meta requirements was data security, heavy use of encryption, making sure that the transfer of data occurred end-to-end on a fully encrypted state. The privacy and the security requirements that sat around that were quite onerous from our side. So we wanted to make sure we were comprehensively capable of meeting all of those security requirements. Manageability wise, those are all pretty much standard that we have today. And I already spoke about making it a plug and play kind of capability for deployment. Those were the big focus for the Meta team in terms of, yes, making it more secure, but also making it easy to deploy on day one and continue doing so.
Understood. Just to clarify a little further, I mean, your Fusion operating system makes the whole hardware more accessible through the cloud. Is this also a key part of this, or was this another specific type of deployment meant only for Meta? That means Fusion was not part or was never looked at it as in this whole setup.
So the Fusion software layer is still in early access stages. It isn't generally available yet. And as and when it does so, it will be available to the Meta team, but at this point, it is not deployed within their data center. Okay,
understood. Now, what about the failure? I mean, obviously, hardware does fail and things like that. Was any failure, simulated in terms of redundancy, fault tolerance, or something? Was there additional? Was that looked at as additionally in the case of Meta?
Yes, it was. One of their key decision points, obviously, was availability. Some of the machine learning jobs and some of the training models will take weeks to complete, and they can't afford to have a pause, reset, restart in that time frame. So the physical uptime of not just the storage hardware, but also the networking, the compute layers, the cache layers were all carefully considered in the Meta design. And we're simply a small part of that with our own availability capabilities, the ability to do live upgrades, hot swap, etc. Those are well understood and have been well demonstrated to Meta over the last few years. So they were comfortable with our capabilities on the resilience and uptime side of things.
Going forward, usually when vendors go into such, specific type of requirements and there's a lot of innovation and efforts put in, then typically OEMs can get a return back or commercial return back from innovation over a period of time. Of course, there is a lock-in period and all that. Do you think this innovation has helped Pure to find other form factors, product innovations in the future which we can use commercially?
The answer to that is probably more nuanced in terms of Pure was already recognized as an industry leader and innovator for the last few years. The lessons we learn, I think, at Meta will be those of scale automation. It will be the single biggest deployment of Pure in a single data center in terms of physical chip density, if you will. So that gives us a huge data set in terms of looking at how a single collection of machines behaves over time, how the various environmentals affect the performance, the resilience from everything in terms of chip health all the way through to power supply status. So for us, it's very, very useful in terms of a field study of a very, very large deployment in a single space. And that gives us and our engineers a lot more data points to work through. In terms of innovation, we always like to work in partnership with our customers. Part of that is helping them to fulfill their business requirements. And if there's something else that we can develop from a hardware or software perspective for any of those customers, that's something we have a regular capability of doing. So as always, we're always looking for good ideas and better ways of doing things. And if we see some of that capability coming from our work with Meta, then I can expect that we will adopt that more widely in our product set.
Okay, great. One important point you mentioned at the beginning was about energy. How does this actually figure in your landscape? Because obviously going forward, every hyperscaler or any large-scale deployment, wherever Pure Storage is, the fundamental consideration over there would be energy requirements scaling with compute. How, independent of Meta, how is Pure approaching the energy consumption part of it in your product?
So energy consumption, power drain, if you will, is a huge focus for us at Pure. We are just about to publish our updated ESG report and guidance for 2022, which focuses on our carbon footprint in general, as well as how we can help augment that for all of our customer base. Power consumption, power efficiency are two of the things we look at most carefully in our design systems. And it's one of the major metrics, in fact, that Meta gave to us in terms of you must be able to meet this particular power draw per rack and with this storage capacity from it. So those kind of metrics are becoming increasingly important. Obviously, with Pure's evergreen model, that sustainability aspect is very, very important too, in terms of, old technology with us gets refreshed, it doesn't go to landfill. And that's a very, very big part when you're operating at this hyperscaler scale. So I would answer that with power, density, capability, data center efficiency are some of the most important metrics for us at Pure. It made us successful in the initial deployment with our friends at Meta. We don't assume that all of the other phases will come with us immediately. We want to just continue to earn that business. But in answering the question directly, yes, power density is one of the huge features and success points with us, not just with the hyperscalers, but also with our cloud company customers, our SaaS company customers as well. So it's something we continue to focus.
Okay, great. Just to come back again to the workloads now, without infringing on any confidentiality with Meta, obviously in consultation with other OEMs like NVIDIA and all, the trillion data point type of use cases, where are we seeing such use cases emerge from? Is it like in social media? Is it like in behavior analysis? What is the frontiers which you can approach when the super research cluster is handling trillion data points with multiple variables? What are the set type of solutions that can be addressed?
I think we have to understand that the RSC is essentially a research and a learning system. It's there to help the metadata scientists and software development teams learn about behaviors and how they can actually make their own technology better. One of the big focuses for them is natural language processing, which is really aimed at things like voice assistants and being able to have a conversation with an AI machine, if you will, on your phone or in your car. Those are the things they're trying to get better at. In terms of the data set, the Meta ecosystem is huge, spanning all the way from the Facebook application through WhatsApp and Instagram, a whole range of others that are much more popular. I don't claim to understand half of these things in my generation, but those are the kind of data sets that they're able to draw on today. I will say, of course, that all of that data is heavily encrypted and protected end to end in the system as part of the key design of the actual RSC itself. So think of this as the way that Meta learns and develops and enhances its tool sets.
Great. I think you mentioned a very important point, which we also read in the discussions about data being encrypted at every stage, and the high level of privacy, which keeps all the stakeholders comfortable. But just to close this conversation, I want to go back again to the energy thing. So we are seeing now about the energy disclosures, carbon footprints become increasingly important for the whole supply chain. So if a certain customer is using pure storage anywhere, do you have the energy metric coming up in a dashboard which they can use to disclose as part of their disclosures, the scope 1, scope 2, scope 3, making it easier? Is this sort of the vision that the energy metric shows up in the operational dashboard?
It is something we're talking about with some of our larger scale customers, yes, in particular those who have their own ESG goals for the next few years. Today, we generally quote our highest power levels, but as you're aware, the power draw of storage technology, in particular NAND technology, will fluctuate lower than that over time. So we are working on giving customers, if they choose, a live view of their power consumption. And we've had some other customers ask us as part of the development of our Fusion suite if they can actually set metrics for power consumption rather than performance as part of that workload. And that is an interesting thing that we are actually looking at. So yes, in terms of energy monitoring, it has become much more of a forefront discussion over the last couple of years. And we think that's a great thing, honestly, because it holds us as vendors to account to make sure that our systems are just as sustainable and as efficient as all the other systems we use around us today.
Great. Thank you very much, Alex. Absolutely brilliant answers over there.